Van Laere is a highly reputable general contractor dealing with practically all aspects of the construction industry. The Antwerp Port Authority has commissioned Van Laere to build a new quay wall to expand operations at oil tanking in Evonik, Antwerp. In order to construct the wall, Van Laere has developed a new innovative construction technique which won the Innovation Award at the Belgian Building Awards 2010. The jury was made up of specialists from the Belgian Building Research Institute, the WTCB, and the Belgian Construction Confederation. They acknowledged Van Laere particularly for their speed, the quality of the work, their focus on the workers, and attention to safety. Up until now, when building quay walls, a temporary protective barrier, a land dike or precast concrete were needed in order to cast the concrete capping beam below the waterline. In the new system, these temporary structures will be replaced by a customized steel limpet that will serve as a dry working space. This limpet makes it possible to cast the concrete capping beam section by section. These steel limpets, or caissons named AQUA-SHELL, are developed and manufactured by Van Laere. The benefits of this technology compared to traditional construction methods are threefold. It saves time, there's minimal impact on the existing waterway, and the finished quality is much better when using monolithic construction techniques for the concrete capping. In this video, we explain how it all works. The preparatory phase begins at the construction site before the caissons can be put in. The former bank protection is carefully removed so as to prevent any rubble, concrete or asphalt from remaining in what will become the subsurface of the embankment. This type of debris would create problems when other work is performed, such as driving in at the combi wall and the tension piles. Tubular piles are driven into the ground from atop a pontoon barge. A special frame is used to ensure the piles are seated correctly. Each tubular pile weighs 30 tons, is 27 meters long and is 2 meters in diameter. The sheet piles between the tubular piles are 21 meters long. Once the combi wall has been put in, the space between the original bank and the combi wall is filled with sand. This is merely the first phase of completion, where the sand is backfilled until just above the waterline. Afterwards, a drain is embedded into the ground, which causes the level of the groundwater to drop deeper into the subsurface. It also ensures appropriate sealing. The final preparations to both the combi wall and foundation are made before work actually begins on the capping beam. The top sections of the tubular piles are emptied and rebar cages are put in. Tension piles, otherwise known as MV piles, are driven into the ground from atop a pontoon barge at a 50-degree angle. These piles are 31 meters long and are prepared for pile driving on site. Next, the remaining water in the tubular piles is pumped out and the piles are filled with concrete. While preparatory work to the quay wall is being completed, the caisson technology has been developed. The design of this special caisson structure is the result of careful consideration and cooperation with specialists from a variety of fields. This is how steelwork, hydraulics, electricity, shuttering, and water pump technologies, as well as on-the-job safety considerations, mesh together in this design. After fine-tuning the design, 2 caisson structures were produced in Anmeco's workshops. Anmeco is one of Van Laere's subsidiaries. These split caissons each span approximately 24 meters, are 6 meters in height, and have a maximum width of 5.2 meters. In the meantime, the first AQUA-SHELL has arrived at the construction site. Given that the entire structure is too large to be transported in one single piece, the assembly of the upper and lower part of the AQUA-SHELL takes place at the construction site. The uppermost section is wider and serves as a work area with space for the capping beam, formwork and the workers. When all the work is complete, the caissons will be disassembled and removed in the same way. Final preparations will also be made before setting out into the water. The caisson joints are sealed with thick rubber to prevent water from seeping in. After this, everything is ready for work to start on the capping beam. AQUA-SHELL is successfully secured onto the tubular piles using winches and supporting consoles. The caisson is then mounted onto the combi wall, and after stabilizing, the limpet is pumped out completely. While work is being performed, two submersible pumps situated at the ends of the caisson will always ensure that the level of water seeping into the caisson does not exceed the level of the scaffold plank in the bottom of the AQUA-SHELL. As a result, work on the capping beam can begin right away without having to build a protective wall or land dike. The depth of water in the channel remains unchanged. In the meantime, the bottom formwork is put in. This bottom formwork consists of 6 panels and rests on wedge-shaped supports. Once the bottom formwork has been positioned, the rebar fixers can be called in. In one single section, they process approximately 25 tons of steel. At this point, the reinforcement is complete. The bollard, hydrant chambers, masonry, conduits for electric cabling and ladders have been put in. The formwork consists of 2 end panels and 5 side panels. These are mounted on a steel frame, which allows them to be easily maneuvered and moved about. Once everything is in order, concrete pouring begins. 320 cubic meters of concrete are processed in each section. This system produces a high-quality result. The concrete capping beam is built using a monolithic technique. In contrast to a prefab construction method, there are no open joints between the prefab skirts and the combi wall on the one hand, and between the prefab elements and the in-situ cast concrete on the other hand. When the concrete has sufficiently hardened, the limpet can be shifted to the next section of the future quay wall. First, the caisson is again filled with water, after which point divers go in to release it. A catamaran pontoon barge outfitted with a special custom-made lifting frame is used to transport the unit to the next section. This lifting frame facilitates the safe manipulation and transport of the caisson. The pontoon barge effectively works like a floating forklift. In transferring the unit, the caissons perform a leapfrog motion one over the other. While this caisson is transported to the next location, the formwork is placed inside the second caisson. In essence, the work proceeds in an alternating fashion. The sections in between are completed at a later time after adjusting the caisson and partially disassembling the side panels. Each week, one single section is cast, while rebar works and shuttering activities for the next section are being prepared. At the same time, a caisson is transported to its next location, which keeps work flowing continuously around the construction site. To conclude the work, a second backfill behind the capping beam is carried out up to the final level. This is how this 860-meter long quay wall was completed in less than 18 months construction time. The advantages of AQUA-SHELL compared to conventional techniques can be summed up in 3 ways. First, the technique saves time, and it can be immediately installed after the tension piles have been driven in and the partial backfill behind the combi wall has been carried out. Second, the impact on the existing waterway is minimal in terms of depth and also in terms of the space taken up in front of the new quay wall line. And last but not least, this system allows for a monolithic technique for construction of the concrete capping beam. AQUA-SHELL provides new opportunities for other applications, such as quay wall renovation or building new quay walls that are required to have a minimum impact on the existing waterway.